How'd we sleep last night? Good. You guys excited to be here? Yeah. Very, very cool. Welcome, welcome. Glad to have you guys here. This is our very first NexGen steel facility. You can see that we have the 3 machines. Chad's going to be giving us a tour. Next week we have 3 more machines showing up. Many of you have asked, this is only 10,000 square feet. 10,000 square feet is a tight fit for 3 sets of machines because of all the stacking and prepping and shipping and everything. I have a 40,000 square foot building in Orem that is currently being built out for 3 facilities plus corporate headquarters. And then we will be also standing up facilities in other parts of the country based on where work's coming in. For example, the $70 million contract coming in next year in Baltimore, Annapolis, we're going to be setting up a shop there. Florida, we're going to be setting something up, potentially New Orleans. We're going to daisy chain and we're going to have a whole lot of fun. So welcome to this place. Before I turn it over to Chad, I just thought for fun, I would show you a demonstration of something. This is NexGen steel. This is Home Depot. There's a world of a difference. Who here is really strong? Do I got a really strong guy here? Asa, come on up here. Asa, come up here. Will you do me a favor? What I want you to do is I want you to try to bend to this. Just face the group here, and I want you to try to put some torque on that. Okay, now swap that out and do that here. Don't cut yourself. Go ahead and break it. It's okay. Yeah. So the reality is, the fact that we have these machines that will allow us to mimic the size and shape of 2x4s and 5x6s means that what you get from Home Depot versus what we're creating is a very different experience. When we say that we build homes 4 times stronger, that's why Marsh McClendon is backing us nationwide, which means any of you home builders, when your families come to buy the home, they have an opportunity. There's a reason why they can save up to 40%. On average, for the average American, that ends up being tens of thousands of dollars over the course of the 12 years that they on average will live in that home. So between getting the home for less, which is solving affordability, and also letting them have the home for less, a better product and a better home, a safer home, and then God forbid that they ever experience fire, that fire is going to move slower. It's going to give them time to save their children or their pets or their valuable documents and maybe keep the home even from burning down entirely. So it's just a safer product for family as well. So we're doing something really special here. We're not dealing in shit. We're dealing here in something, we say that money follows value. But more importantly, we have a chance to change the planet with this product. So Chad's the one that makes this possible. Guys, do me a favor. Give it up for Chad Brown.
This is a really cool place to be, see, and understand. But nothing happens here. Absolutely nothing without all of you. If we can't sell it, if we can't educate and we can't show people, then we don't even turn these machines on and these guys don't even have jobs. So while it's really cool to see all this, I want you guys to really feel how we understand the importance of you. This is what has changed the way that Chris and I approach this from a 3 to 5 year exit, which is what we were both starting with, to the phone call I got from Chris last week or the week before when he said, man, there's so many people that see the value in this. I think we have a moral responsibility to honor the stewardship of what this could be if we all do this together. So there's no 3 or 5 year exit plan for he and I. This is like, let's run with this. Let's make this the last step. So here we are, just thankful to you. This is all because of you. So we're in this now together with you guys. So understand also, like I'm going to tell you about all these machines. You're going to be able to see a lot of really cool things. The assembly team and the production team are going to produce and assemble. You're going to get to see how loud it is, how cool it is, how manly or strong womanly it is. Strong womanly, that was cool. But also understand what you're doing. So the last 5 years that I built of my 30-year career inside of home building, I started to really understand what I was doing. And what I mean by that is not from the technical sense of building a house. I started to understand what I was doing, meaning I was taking a young couple and putting them in the most expensive investment they would ever invest in, where they're going to raise their family. And so, I mean, I even get a little emotional now talking about it because that's what we're doing here, is we're giving families a chance to own a house that is worthy of their investment, that is worthy of raising their family, And that is why this works. So understand as you have conversations with builders and individuals that we're not just selling steel, we're not just producing houses, we're truly changing lives. And that's going to kind of be the theme as we go through the day, because when we get back to the event center, what Chris is going to share with you guys is you're going to understand what you're a part of. And I'm not downplaying that any of you don't, but you will really see it as we go through this day. So just be open today to what this could be for you and for the people you come in contact with and share this technology with. Cool?
Yeah.
All right, so when I do these tours, I like to do them as if we are the raw steel. It's like you are the raw steel that comes into this factory. So what happens when raw steel comes into the factory? Before raw steel comes in, it starts at Nucor. And Nucor is our supplier. It is 100% American-made recycled steel. We talked yesterday that we can adjust and change the recycled content depending on some project requirements. It's an amazing thing that we can do that. But typically 25 to 30% of what is in these studs is recycled. So even at our lowest level of stewardship, we are helping the planet and saving trees. So when it leaves Nucor as about a 5 foot wide, 20,000 pound coil of flat steel. As we walk around, you don't have to look now, but there's a couple of raw coils we have loaded on the decoilers, and you can see that it's not 5 foot wide. It's the width that we need to put into our machines to produce these profiles. So we buy these 5 foot wide, 20,000 pound coils of steel, and they come 2 on a truck, because a truck, an 18-wheeler, has a max load of 40,000 pounds. Sometimes we push it over that a little bit. But 45,000 pounds is about the max a truck can carry legally on the road. Then it goes to a slit facility before it comes to us to be slit into the widths that we need to run these machines. And that's how it comes into the factory on pallets of 3 or 4, usually 3 coils that have been slit to the widths that we need. Scottsdale has really got it down pat. And what I mean by that is they designed their entire machine army around 2 slit widths. So you have a 6.81 that goes into the 2x4 machine, which is what this is. And it also goes into the truss machine, which is what this is. So 1 slit width services both of these machines, and then the 5.5-inch machine has 1 other slit width. So when we place our orders with the slit facilities, we're only ordering 2 slit widths, and we typically only use 2 gauges. We use a 20 gauge and an 18 gauge. Under extreme circumstances, we'll use a 16 gauge, a heavier gauge on the truss machine that we have. That's a 3-inch truss machine that's not here. You'll see those 3 painted orange spots. That's where those machines are going. So we have 3 more machines en route from Texas for next week. And so the steel that comes in that's ripped into these 2 different widths and 2 different gauges is what gets loaded onto the decoilers and runs through the machine. When we start walking around over here to the machines, we're not going to do it now, we're going to have time to do it later. You'll notice on the machines there are various what we call stations. As it comes in off the decoiler, each station does a little bit different bend until you end up with this profile, which is a C channel. And then this lip is proprietary to Scottsdale. You'll get to see that closer. And these are the 2 ribs in the web that I told you about yesterday. That's the proprietary ribs. The stuff you buy in stores and from Home Depot has no ribs. Those diamonds do nothing to it. So that's why Asa was able to twist this up with his hands. So it goes in and it gets shaped through these various stations so that by the time it comes out of the end of the machine, which is what we call the tool head, by the time it comes out of the tool head, it has this shape. Now inside of the tool head, everything that gets punched, cut, flattened, swaged, all happens inside of this tool head. So it gets shaped into a C channel, enters into the tool head, and then all this cool machining happens inside of the tool head. So that when it comes out of the tool head, it's a finished product for the piece that it is. So we end up with pieces that have notched ends, flattened ends, all the tooling. If we were punching any of this for electrical or plumbing, all that happens inside of the tool head. There are 2 different plumbing punches inside of the tool head. There's one that matches the electrical, and there's a larger plumbing punch. All that happens inside the tool head. So when it comes out, It comes out and the guys stack it like this. This stack that you're looking at is actually one of these tables. These are one of the things the guys are going to assemble today. So when it comes out, they have a guy that runs the machine, that's the operator. They have a guy that's a stacker that stacks this, and then they have the assembly team. We have a stacker because the machines can run a lot faster than the assembly team. It's not that they're slow, it's just that you're talking about machinery and robotics versus human interaction trying to get all these pieces in and get rivets into it. The way that we keep up with the machines as production picks up is we increase the number of assemblers in the facility. Even at that point, we're running the machines at about 80% capacity when we're wide open, which is a beautiful thing. The older machines that are coming in, those are 3 of my older machines, we can just about keep up with those. We can't keep up with these. So that's a beautiful thing. That means that we can run wide open at 80% capacity and we don't have to kill the machines at 100% capacity. Where all these punches, this flattening, the notches, the punches for the MEPs, where all that comes from is from the design. So you guys know, you've already seen that when you send a set of plans in, we send it off to the design team. It comes back and there's a 3D model. That 3D model is the first rendering of the run files that will actually tell the machine what to do. So when Bobby starts the machine later on and you guys get to watch this, you'll see where the computer on the machine is actually telling you what parts are being printed, what percentage of that print of that particular part is. Then it's going to have a part number. It's got a part number, a wall number. You'll see some printed markings when you walk around and look. This is W1, this is wall 1, part number 19. Each wall, whether it's a table, whether it's a 1-story house, a 3-story building, goes together in the same order. So when the guys are assembling, they don't have a set of plans, they don't have a tape measure, they have their rivet gun, rivets, and the numbered order that this stuff goes together. For my builders and framers and people who've been reading and starting to understand how construction goes together, every wall panel that goes together in the same order. Number 1 is always the bottom plate. Number 2 is always the first stud. Number 3 is the top plate. And then it fills in from left to right based on the rivet hole location. So the guys understand this very easily after they start putting it together. They already know 1, 2, 3, and it fills in. So it doesn't matter then what they're building. They don't care. What's really cool is that they don't need to know that and they don't have to think about it, right? They just need to know their order and they can run through it. The reason they don't need a tape measure is everywhere it gets flattened and it gets a rivet, gets a stud. So if we have it set on 16-inch centers from your rough order magnitude worksheet that goes to the design team that designs it at 16-inch centers, every 16 inches this gets flattened. If it's on 2-foot centers like this is, the guys don't need a tape measure when they're putting it together. It gets flattened. So they know that everywhere there's a flattened space, a stud goes in, they twist it, they rivet it in. How cool is that? You can put together a table or you can put together a 4-story building and you don't need a tape measure and you don't need a set of plans. That's super cool. That's absolutely insane. What we do like to do and what's really cool for the guys in the shop is, and it's going to be a big push for what we're doing here at NexGen, we're going to have a TV screen up and we're going to have the projects that the guys are working on the TV screen. So that as they're being assembled, the 3D model will show them what they're assembling and it'll show them how far along they are in the assembly process so that they know what they're contributing to out in the field, whether it's a building, a home, whatever it is. That's pretty cool. The other piece I want to share with you too on the technology side is everything we do here is going to be through a scanning process. So it's going to scan a barcode on each piece. And every time your project wall passes through a certain part of this assembly process or production process, it'll be scanned. And so it gets tracked inside of our ERP system so that we know exactly where your project is, what percentage it is in completion, and you're able to communicate that with your client. So there's a lot of technology that we're bringing into the facility as well, not just on the design side, but in the production side to give us and you guys certainty in how to communicate with your clients on where their project is. The cool thing about that is on the delivery site, when it gets delivered, it gets scanned in again. So we know that it was delivered and we know the part's there. But as it gets erected, it can also be scanned so that each piece that gets erected or stood up, whether it's a wall or a truss, builds a 3D model on a screen. So an owner can pull up, if he's on an island in Hawaii, he can pull up his 3D model and see exactly where his framers are at, because each wall at the end of the day that's been erected gets scanned in and it builds the 3D model digitally on his phone. That is really cool. So if you're a developer, if you're a builder, and you want to spend some time with family, take a vacation, you can know exactly where your project is at based on that 3D model. Okay, getting back to the facility. So it runs through the machine, it's tooled, it's stacked, it's ready to be assembled. It gets assembled. From assembly, it goes to our stacking area where the finished walls get stacked. We typically like to time that to the builder or the homeowner's desire of receiving the material. In other words, we established a project timeline of delivery first, and we work backwards in the production process. When you have multiple jobs going, this is critically important, because if we just print them in the way that we get them, we'll print a project, have stacks of walls back there, but they won't want that for another 2 months. And so we're sitting on valuable warehouse space stacked up for 2 months. So just so you guys know, we time our production schedule based on your client's need for the product. So understanding the project schedule is super important, because we do what's called just-in-time manufacturing. We like to time it to where it's just in time for the homeowner to receive it, so we don't need a large warehouse or yard to house it. When you're having conversations with your clients on the sales side, on the front end, after you've gotten your delivery deposit, that's one of the biggest conversations too, is when are you guys going to want this? Because we adjust our production schedule that way. And another one is on the commercial side, what order in the building are you building this building? How do you want to stand this up? Because the way that we send it out is determined by how they want to build the building. I told you yesterday about the 4-story, 60,000 square foot dorm building that I built. We actually had several planning meetings on, hey, we're going to build it east to west. And so everything that we send out had to be east to west. We're going to build east to west north wall, then east to west south wall. And so as the building went across, the deliveries come out, and we're super efficient. On the larger projects, the project managers, owners, architects love that sort of planning. We can do BIM models to create what that looks like. There's some BIM people here that understand that. So we can model the actual timeline of the construction with how everything is going to go together and how it's going to be delivered. So there's a lot of technology, is what I'm getting at, to back you guys up on your sales, to give you certainty in your conversations with your clients, and to give you understanding of how all this works. It's like, okay, there's been some questions come back to me. It's like, okay, well, if we sell a bunch of stuff, can we produce it? Can we deliver it? And so all these conversations today are to give you certainty in that understanding, not just about the machines, but about our process behind the machines. Make sense? All right, I'm going to stop for about 5 or 10 minutes and just take some questions. Who's got questions?
If you have a builder that's producing 20 a month, how's that going to work if you guys are producing 1 a day?
So, great question. 1 a day is the way that we give people a visual to understand what can be produced. It is not all that can be produced. So it's an example to a builder that he can get right away. Oh, you can do a house today? Okay, that's cool. We can do way more than that, because we're not running a single shift, and the way that we produce the parts and pieces can outrun the assemblers. So if we need to produce 3 a day, we're going to run the machines to produce 3 a day, and we're going to have stacks of houses for the assemblers to assemble.
This is, I think, also a good moment to understand, how do we keep up with demand, right? So if demand is coming in hot and we're getting a lot of projects, the question is, how do we keep up with that? You have 14 people and a production manager that are running this shift. But these machines, even though our first shift is a Monday through Friday, 9 to 5, the next thing that will be augmented is we'll be moving to shifts where we'll be running, for example, 4 different shifts where we're doing 3/12s. What that does is that allows the machines to literally be run almost 24/7 in the same facility. So whereas this set of machines might normally max out at, let's call it $20 million a year, on 4 shifts, now you're looking at $80 million a year. And the time that it takes to hire a crew to start another shift is under a month. Yeah, so I want to answer this question. So when the question is, what happens if I bring on a builder and they're doing 20 homes a month? Right now, we have investment for doing 7 machines. Those 7 machines at 4 shifts each, that's 28 shifts. That 28 shifts gives us the ability to basically print, if we want, 28 houses a day is maybe a way to think about it. Yeah. And then as far as gaining investment capital to continue expanding, That's the easy part. Just in the last week, Chad and I have people throwing themselves at us, not to invest in the company, but to actually partner on a facility and put up all the money on a facility. And one of our strategies is we're actually saying no to the money unless you have a list and you can help bring on 200 affiliates. And what it does is we're now creating an even flow of having the number of affiliates to the number of facilities, and we're just gonna expand this until we stop cutting trees down.
So to just piggyback on that question, how many facilities and or machines do you need to capture the market share goal in the next 3 to 5 years?
So right now we are funded to capture the market share goal in the next 3 to 5 years. We can capture our commitment to our investors with the funding we have. We need no other funding. But I want to just say this, but what we can't do is flip the market from the funding we have. What we can do is capture 1.16%
Right.
of the market share.
So that was my next question. Is there a growth plan and an investment opportunity as you guys continue to set market share goals?
So Chad and I have decided that changing the industry is more important than just a company. Because at some point to achieve that, we have to do something bigger than just the two of us or the group of us. So what we're doing is we're exploring ways to foster collaboration in the marketplace for expansion to help, if you will, our competitors come into business successfully and win. And when I say collaboration, obviously it's to make sure people don't step so much on each other's toes, but that it's a series of companies working as a team. Ideally, we're going to do that in the form of some type of joint venture so that everything is powered by NexGen so that we can basically help reformat the entire industry.
Yeah.
A comment. I just want to call out the intention, the level of intention from the production to the way you load the truck is so impressive. And it correlates, and you can see it paralleling through even the growth strategy. So high five. Like, that's so awesome.
All right, thank you.
I really appreciate that.
My question is, in this initial startup phase, if one of the machine goes down, what's the backup plan? What is the strategy for making sure everything's getting printed in high demand? What's the strategy there?
That's a great question. One is, like I said, shared yesterday, that Scottsdale is a symbiotic partner with us. They get paid royalties for every foot that comes out of the machine. They get a royalty. So they want these machines running. So they're instantly there for us. When Scottsdale was purchased by a US-based company, that put all the parts and everything in Denver, Colorado. So we would used to have to order from Brisbane, Australia. It would have to get shipped from New Zealand to Brisbane, from Brisbane to here, have to go through customs. You know how that, it was a nightmare. So there were a large inventory of extra parts we would have to keep on hand. So we have a strategy around it. I'll share it for 2 minutes. One is we keep what we call a large backstock of consumables, which are factory machine consumables. So everything is high pressure hydraulic. 2,500 PSI is what the machines run at, to about 3,000 PSI. So it's a lot of O-rings, a lot of washers. There's very few things on the machines that break. The other is hoses, there's hydraulic hoses. All this is locally sourced, easily found, and we have a backstock of it. Then the machines are run by chains. So there's a series of chains that we keep, lengths of chain, and we make it to the length we want when the chains break. Outside of that, there's very little to break on these machines, very little. But when they do go down, when you're talking to a large volume builder, one of the large volume builders' issues is going to be redundancy. They're going to want to know that when we place an order for 500 homes, I don't care if your machine breaks, I want my houses. So we have to build into that redundancy. We have it here because we have another set of 3 machines coming in. So we'll have backup for what these 3 machines can do. But as we grow and expand, that'll grow our redundancy and make us more relevant in the eyes of these larger home builders.
I would also add that having one facility, if something goes down, then you have to wait for it to come back online. When you have a redundancy of facilities, it means that the facilities now are collaborating. And so once we get our next 3 or 4 facilities up and going, that redundancy means, hey, something catastrophic happened. This machine's going to be down for a week. That's not catastrophic. We have the ability to rebalance. And so having a redundancy of the machines will help us do that. Great question.
Here, I want to finish this one piece and we go to another question. Here's the last piece of this that that you recognized. Part of our growth strategy that Chris just talked about bringing other investors in for a joint venture completely separate from what we're doing under this investment structure here, is for that redundancy factor. So it also, and here's the thing, if you look over at Australia right now, within a 2-mile radius, there's like 6 or 8 shops, and I told you this yesterday, doing $30 million. Literally, we could have another joint venture shop open next door, and it's just another avenue for you guys to push work through. There's that much, you have to realize the abundance of work that is out there. There's just that much work waiting to be done. We just have to convert it.
Where are you guys assembling this stuff at?
Assembly happens right here, or it can happen on the job site, depends on the builder. So a lot of it happens here. You're going to see it. It's going to happen in a minute. We're going to turn the machines on, and you're going to see the guys assembling. So it's assembling here, and it's being shipped out of here. We also are in the process of getting an overflow yard close to here that we're going to put a tent up on, and we'll be assembling under a heated tent and for the overflow areas.
Is this the only facility right now?
This is the only facility right now.
Yeah.
So we have a 40,000 square foot warehouse in Orem that is being retrofitted.
This is temporary. We had to jump here as that. We got ahead of our remodel in Orem. Chris already owns the building. It's his building. That's going to be our corporate headquarters, and it's 4 times the size of this. So this is a Band-Aid until we can get that building remodeled, finished, and get into that building.
With the human factor of shipping and all the things that can go into moving these things to the different sites. That being said, as far as dealing with that aspect, truck breaks down, there's a storm keeping things from coming in, whatever. So are we giving people a window of time that this is going to arrive, or are we trying to be within like a 3-day, 2-day? I mean, how are we setting that up as far as letting them know that it will be there, but it could be a few days earlier, a few days later, whatever, to deal with that side of things?
Yeah, so we shoot for dates, just like if they were ordering a lumber order. Same thing. It comes in on 18-wheelers, just like it's subject to weather, just like it's what they're used to dealing with. But we shoot for dates, and if weather dictates something different, then we just make an adjustment. But we shoot for dates.
That means there's not a plus or minus 3 or 5 days or a week, or we'll get it to you when we get it to you. This is a precision operation. Does everyone understand that? What you're experiencing here is precision, which means that when we say it's going to ship on the 17th, it's going to arrive on the 17th.
Mine was just a piggyback on that, actually, is like, as you know, being a Marine, bad shit happens, right? So what happens if, when it shows up, it's damaged in transit?
Mm-hmm.
So how does the builder recover from that, and how do we step in to support the builder? And not that I'm saying it happens a lot, I'm just saying it happens, and when it happens, that's the builders going like, this is ruining my day.
Mm-hmm. So contingencies, right? That's what we're talking about, contingencies. And everyone knows the plan is the plan until we start. Then the plan is no longer the plan. Right. So what we do is plan for when the plan's not the plan. And what that is we send links of studs like this for bracing out to the job site with everything, so that if a stud's damaged, gets rolled over, gets bent, whatever, there's easy ways to drill the rivets out for the framers, pop a new stud in, pop a new bottom plate in. It's super simple. Okay. Yeah, it would be the same thing as if you were ordering wood and you had wood break. There's ways to repair wood truss. There's ways to repair wood panel walls. Same exact things with metal. Next phase is this. We're going to fire up the machines. Give Bobby a minute or 2 to get that running. We're going to assemble. Bobby, where are we going to assemble, or Trent? We're going to assemble here? Okay. I have to move my coffee. We're going to assemble here. So what I told Bobby to do, what I wanted you guys to feel, is what it is like when the facility is producing, right? So we were going to just run the machines because it's not as loud, and then assemble. I'm going to do it all at one time because I want you to hear and feel what it's like to be in the assembly process. Now, our assembly guys have been working at this facility for what, about a week, guys? So about a week into this. They're learning it really quick. It doesn't take long, but they get more and more efficient. So what you'll see is they're going to put the studs in this place as they go. They're going to twist them into place. They're going to get rivets lined up, pop rivets in, and as they do that, they're going to work down the wall in a numbered order, and they're going to end up with a wall panel for a table. You guys ready to see this? Yeah. Awesome. All right, cool. Fire it up, Bobby. Yeah, just work on around this way, guys. It's really cool to see the computer and how that works.
Now, later when you get a chance later, this plexiglass plate allows you to actually watch the formation of the steel, the cutting, the process as it finishes coming through here, and then final, it gets printed on. This is a big ass printer.
So each one of these black things on top is a solenoid. You'll see it light up each time a function happens. That's pushing, hydraulically and electronically pushing the tool into the tool head, into the piece of steel to produce whatever function it's doing. So it's really cool to watch the top of these as well.
So being that this is the ground, the first number one is to go with number two.
We already got him. I got one.
And
Production.
just put that in there.
Nice.
Sweet.
I like that.
Got this hole puncher so that we're not messing with it too much. And then what?
Chris, this video you know what it was?
Yep.
Line these up for you and we'll give you a dribble gun.
Yeah, this is a full switch for me. I'm used to nail guns and all that, but I've never riveted anything, I don't think.
All right.
Here we go.
Now, he's going to take this gun. It's preloaded right now.
Yep.
You're going to take this part and you're going to force it into that hole before you drill anything.
Okay.
All the way.
All the way down?
All the way.
Push down. There you go. And now
Pull the trigger.
Pull the trigger. That's it.
Boom!
You push it all the way in first, and then
Pull the trigger.
that's it.
Wait, I'll take that.
Yes.
So like, hey.
We're ready.
All right. We're going to have you take that first part and just push it all the way in there with some pressure. Straight up and down, push down. And now pull the trigger. There you go. That's it. All right, we're gonna let the team here get going on the table. We're almost done printing over here. They're gonna assemble it together as they do that a little bit. We'll see if you guys have questions or anything. If you take a look at the pieces, one of the things that's interesting is these C channels not only strengthen the geometric structure, but it also makes it safer to handle. You'll notice that these are pushed in on their pins, and so they're countersunk with their partner here, so they're already roughly holding each other together before they're actually riveted. All right, I'm gonna let you guys keep cracking on this one. Where's Chad?
To the contest.
Yeah, we're gonna do a little bit of question while we're doing that right now. What's your question?
Oh, the question was, yesterday Chad was talking about the inside being webbed. Is that where the indentations are?
Chad, we're talking about the webbing.
Okay. Yep. So those two lines in here.
Yeah.
This is patented specifically for Scottsdale. Yeah. You will see no other stud with this, but it gives us a lot more vertical load strength. So it keeps deflection in the stud down. So that is what that's there for.
So that's our design exclusive.
That's our design exclusive, yeah.
Yeah.
Well, a lot of what you see here is design exclusive, but specifically as far as gravity loading, that's specific to us.
Pretty sure that there's no edges that are like easy to cut or not like section.
It is. It is. Yeah.
Okay, so here's what we want you to envision as this is being assembled is someone's working the machine to put out the pieces and properly pre-stack it. The immediate next team is now coming and doing the assembly, and then there's a team after that is then stacking it, and they're stackers, and they're basically stacking it in proper order, so they're basically preparing it for shipping. And so now you start seeing what the process looks like with uploading the plans, printing them out. You've got the receivers that are then assembling, and then you've got stackers. Those are the three dominant roles that you have in the facility that basically get it ready to go out the door.
In course.
Question?
Hey, thank you. For Chad, I think it's good for the investors to know and us how the quality control works for the machines and for us before we put it out to make sure everything looks good. Mm-hmm. And hopefully everybody can hear me okay.
Yep.
Trying to talk loud.
So the question is, how do you do quality control in the facility?
So for the investors, this is big for you. Also big for your relationship managers, but for the investors, we have a very stringent quality control process. I'm going to run you through just at a high level what that looks like. So you have humans putting in rivets. Every now and then rivets get missed, obviously. Like, you're rolling through production. Who checks that? So we have a person that checks that. But the quality control starts back at the raw coil. So raw coils come in with an ID tag glued to it. As we scan them in, that tells us metal, I don't know how to say it, but it tells us what's in the metal. So it gives us the gauge, and we take and track that to the specific job. So when we have a job running, we scan the steel in. It lets the machine know we're using the right gauge for that job, and it will not print unless it's the right gauge. The computer won't, he can hit print all he wants, it will not print. Metallurgy, yes, thank you. So it has the metallurgy in the on the tag, and then that gets scanned in. As the pieces are coming out of the machine, Bobby or the operator will take a tape measure about every 8 or 10 pieces and just check the measurement on the piece. That measurement is shown on the screen, so it's making sure the machine stays calibrated. Every now and then that gets off, because when it gets hot and cold, the metal shrinks and expands. That has to be tested, so that gets checked about every 10 pieces. Rivets get checked on as they're stacked. We have a person that checks the rivet locations. Same thing in the truss. There's certain spaces in the truss where the bolts go through. We're not going to do a truss today, but the bolts go through and connect the webbing to the top and bottom cord. There's spacers that go ever so often. The computer prints or shows where those spacers go. We have someone that comes back and checks those spacer locations. So those are physically checked by humans. It's done by the machine and then done by humans on the backside. There's a lot more to it than that, but that's a general understanding of how we maintain quality control in the factory.
Can you explain the difference between these rivets and others?
Is there a grading difference?
Okay, so our rivets are zinc coated. Other than that, there's nothing special about them. They're not structural rivets. This is a cool thing to know because you will get builders or architects or engineers ask you, how does the building hold together with rivets? The rivet is not the connection. And now this is in the building code. The connection is a convex and a concave dimple going together. So the back side of this is a convex. The other side on this piece is a concave. Those two dimples go together and they cannot shear. That is exclusive to Scottsdale. Then the rivet comes in and just holds that convex and concave dimple together. It's all it is. So it used to be the shear value of the rivet mattered. When is the rivet going to get cut? Doesn't matter anymore because the dimple, the way we do it, our dimple holds the connection together.
Do we have access to the proprietary bolts that you guys were talking about? That Scottsdale has, is that here or not yet?
That's in the U.S. Yeah, that's all U.S. based. No, yeah, we have bolts here.
Okay.
Yeah, we have some bolts here. I'll pull the bolts out. So the proprietary bolts have a shoulder on them. They're made specifically for our truss by Nucor, and they have a glue on the end of them. They're dipped in glue, kind of like Loctite. And then the nuts have a nylon inside of the washer. So when that goes together, it's done. It's like almost being welded.
Get that? Are these off center on purpose?
Yeah, they're all centered on purpose because that lets them know which way the stud goes. So if they put the stud the other way, it won't work. It'll be here. Yeah, so they all center on purpose.
They can't even put the studs in the lock.
They tried to take all the thinking out of it. So when this was designed, it was designed because the labor in New Zealand comes from the islands around New Zealand. They're not educated people. And so they're beautiful, hardworking people. They're just not educated. So they had to make this as simple as possible. And it just translated into our market as well.
Given that all this stuff is custom made, if something gets damaged between our facility and the job site, how do we make sure that the installers can continue working or replace something that got damaged along the way without delaying schedule?
Yeah, so we send extra parts with every order for bracing and for dead wood and for what may be used, but a lot of it is used for that. So it can be cut with a grinder instead of a skill saw. Use skill saw with lumber, use a grinder with metal, and then you have screws that you use a screw on and put it together. Super simple.
So everyone, I want to see if you understand this really important piece. Up until now, before visiting the factory, what you're likely thinking is they're just grabbing metal like they would from Home Depot and putting it together. Are you starting to see the differences, that it is cut to size, that they're adding in the bending of the metal, the webbing, which creates reinforced structure for extra load, that the convex and the concave fit together, that the assembler can't even assemble it in the wrong order, or the machine can't even print with the wrong gauge steel. All of those measures is what turns this into a system so that the factory can just pump and go and have as little human error as possible.
What do you call these grooves in the back here again?
So those are web stiffeners. Yeah. So those are web stiffening grooves.
Are all the information you're giving us today, is that going to be in ChadBot?
Is all the information that we're giving available today on ChadBot? And the answer is everything in this camera, Carson is feeding into ChadBot, and ChadBot knows all this.
All right, so look, who asked about the bolts? Okay, so these are the bolts. They have a shoulder on it to keep the installer from crushing the truss. So when he runs it down with a gun, it stops at that shoulder. So it keeps the truss from being crushed. Also, it's dipped in a glue, and the washer is like a nylon washer. Once that goes on, it doesn't come off. There's a spacer. This is a structural piece. The computer tells the installer where it goes, and the operator marks the location. So what he'll do is take a black marker and loop it. And when he loops that hole in the truss, the installer knows when he puts the bolt through, he's got to add a spacer there. That's what the QA/QC guy is looking for on the backside, that everywhere there's a loop, that there's a spacer. This doesn't happen often. This is maybe on 1 out of 5 truss in 2 locations on that truss. So we don't use a lot of these, but it does happen.
Are you guys 2 foot on center?
The question is, are we 2 feet on center? Let's talk about spacing and the structural engineering aspect.
Yeah, so whatever we design it as is what the machine punches it as. This is on 2 foot centers here, but we can do it on 6-inch centers, 2.5-inch centers, 16. We can tell the machine to do whatever we want, they'll do it. Right, these are 2 foot.
When builders ask me the question, when this is seated on the foundation, whatever that is, where does it hook? What does it hook to? And is there anything that goes under it?
Yeah, so whenever this goes onto a concrete foundation or a wood foundation, because believe it or not, some guys still do a wood foundation and go steel from there up. It's okay. We use sill seal, which goes in between the bottom plate and the concrete. And then we don't use any anchors in the pouring of the slab. All the anchoring is post-pour. So the installers, they'll have a drill. They drill down in about 6 to 8 inches deep. That's engineering determined. And we use what's called a Titan HD bolt. It's a Simpson bolt. You can buy them anywhere in the U.S. It's got a washer on it, and they simply put a big screw or a big bolt every so often on the bottom plate.
So one of the questions that I got, Chad, yesterday from the builder was, your slab isn't poured flat.
Right.
But the material is true. So if you stand up true material on a slant, everything shifts. How do you correct for slabs that have more than a half-inch variance?
So there's two things. One is, I told you guys yesterday about the old way we used to do it is everywhere there's a bolt, we would stack washers underneath to take up for a half-inch belly or 3/4 inch belly in the slab, whatever it is. I got back to Chris's house last night where I'm staying, and it was bothering me. So I did the smart thing, and I called my superintendent who actually puts his hands on it. I said, hey man, what are y'all doing now to correct these bellied slabs or out of level slabs? Y'all still doing washers? He's like, Chad, we hadn't done that in years. I said, well, what are you doing? So they take these, if you'll stand this wall up real quick. No shims even. They take this plate and they snip it so that the plate can bow, the bottom plate. Then we have studs, which they're stud extending studs. They slide together. They're taking the adjustable studs, putting them in the location after the plate bellies so that the top plate stays level, but the bottom follows the belly. Super cool. It's exactly what you would do with timber, except now we're doing it with steel.
How about removing the studs? How easy is it to remove them?
It's a drill bit, a 1/8 drill bit into the rivets on each side. They pop right out.
My question is, if your builder, say he wants, I just want a whole 50 or 100 studs of a certain length, and he just wants to call up the facility and say, hey, I just want this. Can he skip the design process and you just ship him, a certain, either just straight studs, or maybe he just wants a wall, something simple? Does he get a discount if he's somehow just giving you certain dimensions and he can skip that design process?
Two parts to that answer. One is we do not sell just lengths of stud. So we don't sell that. We're not set up to do it. Our pro forma, our pricing model is not that way. We're set to send out designed pieces of material. What I mean by that is, if someone wants one wall, we will put it through the design process and it will be engineered and it will go out and it will perform like it's supposed to. We do that because that gives us coverage on the backside for liability. So anything we send out, even if it's a backyard shed, we'll have an engineered stamp on it. That way we're covered.
If Fido needs a doghouse, that doghouse will stand the test of time. It will survive the second coming.
So the guys that do the HVAC, they have a dryer vent that goes up through the middle of a 2x6 top plate. They end up cutting out 3/4 of that top plate, and then you need plates on each side of it to hold it. So if they take this stuff and take a grinder, cut out what they need to cut out, are there plates that go across that, or is it still going to be structurally sound?
So a lot of the questions like that I answer to a builder or to an architect or engineer or homeowner as if it were wood. So I can tell you as a builder, if you give a plumber or an HVAC guy a Sawzall and tell him to create his own pathway for his stuff, he will create his pathway and you will be fixing it after. So it happens in wood too. What happens in that situation is you can take flat strap on each side of the plate and repair it, because the only structural piece to this wall right here, it's really structural, is in line with the studs. So you'll see that when we put a wall up, our floor truss or our roof truss fall right on a stud so that the load path keeps going. So if they're cutting out a section here, we simply have a repair where they put a strap on each side just to continue the plate.
In ideal construction, that always works.
Yeah, in ideal construction, that always works. But look, if you've got a subcontractor hacking up your building, you've got an oversight problem.
Do we have anything that we can see today for punching for MEP afterwards? And,
yeah,
and where that falls in the studs?
Hey, Bobby, will you run a section and punch an electrical hole and a plumbing hole in it? So Bobby's going to run that, and that way you guys can look at it, pass it around. So there's a specific size for plumbing The plumbing hole, the plumbing punch is oval. It's that way because it's structural. So you can punch a bigger hole that's more strong if it's oval rather than round. The electrical holes are round. And there are grommets that any electrical supply house sells that goes into these holes so that electricians can pull regular Romex wire through those holes. Doesn't skid them up. Electricians love it. So we'll go and punch the entire house where we know he's going to run electrical or where the electrical plans say that his routing is going to be. And his guys can go in and simply pop the grommets in and start pulling wire. There's no one day of drilling holes in the entire structure.
And that also be used hot plates?
Yeah, it is done in the top plates. Yeah, so we have vertical routing and horizontal routing.
Chad, a little bit of a technical question is,
Yep.
as we're starting to use this material and we're getting our subcontractor bids on electrical and plumbing and things like that, obviously there's a time saving for their work because everything's pre-punched. How do we explain that to them so we can start to share some cost savings with the client from that measure as well?
Yeah, so how do you share the time savings that the plumber or electrician experiences with what we do? The best way to do that is with the true cost comparison on the bids in the beginning. Start the conversation with the high level people. So if you can show them where other builders have saved, they're going to want to save. What I've seen happen is a plumber or an electrician has to do one house to get it because they're terrified of it. If they're shifting from wood to steel, they're scared of it. And so they have to do one house to see that it is what it is. Then typically the builder goes back and talks to them like, hey, we're saving you a day of drilling and punching. You know, how can you help us here?
Like when we have like a floor down and we're attaching like tongue groove OSB to fill the gaps, are we screwing that with self-tappers or is there a tool that will speed up
into the truss, like hold it down the truss?
Hold the board.
Yeah. So to hold the subfloor, whatever material it is, down to the truss. All right, I'll answer that question 1 second. So this is the electrical hole at the top. I'm gonna lay it up here on the table. You guys can look at it later as we walk around. This is the plumbing hole. So plumbers love this. They can just come in and start putting pipe inside of their holes. They absolutely love it. They don't have to have a grommet or anything like that for their piping. The electricians pop a grommet in this hole. So if there's a lot of wires going through a particular location, we'll put 4, 5, 6 of these holes in one stud so the electrician can just have a chase way to pull his wiring through. Make sense?
That's okay with PEX?
Oh yeah, this is okay with PEX for sure. Just about every builder that uses it runs PEX. This is drain. This is for drain. Yeah. This is typically a drain line. Or if you have a bundle of PEX, the plumber will say, "Give me one for my drain and give me one there for the PEX to run." So we'll put them back to back. Now look, on these, we only punch these to where the builder or the trade asks for it. Every punch slows the line down. That's why our studs, one, to keep them strong, we only punch them where they needed, but we don't put random punches because each time the machine stops the steel for it to be punched. So if you've got a lot of punches, it's going to slow the amount of production you can do in a day, so we keep that through the design process to a minimum. What was your question again, man? I'm sorry. Oh, how do you hold it down? Yeah.
Hold it down. Is it screwed?
Yeah.
Is there a tool that you can?
So on the truss, for you guys that want to know how the subfloor attaches to the truss when you're building a 2-story house, whether you're using Advantech, OSB, CDX plywood, whatever it is, there's a screw that we suggest. There's two things, and we give this as part of the installation instructions to the builder and the framers. Over the years, I've learned that I have a lot fewer squeaks in my projects when I run tape across the top of the truss. So we tell them what type of tape to purchase. It's a black tape that rolls right across the top of the truss. It's real cheap. Then we advise putting the plywood down, and we use a special screw. The first part of the screw has wood threads in it. The second part has machine threads in it. That particular screw does a wonderful job of holding any subsurface down for the floor. So all that is in the installation instructions. Yeah, what you got, brother?
Has anybody ever used a subfloor spray foam adhesive to eliminate the squeaking?
I have been seeing that a lot. I follow a couple of framing companies on social media who are advanced in what they do. Awesome Framers is one. Y'all ever seen those guys? They're pretty cool. They're wood framers, but they do a lot of stuff like that. I haven't tried it, but I'm sure it'd be amazing. Yeah, I'd love it.
So, same for the roof deck with the same screws?
So for the roof deck, no, it's a different screw because of I'm not going to go into explaining why, but it's a shorter screw. This is a longer screw that we use here because we have to get the two types of threads. But for some reason, the guys use it. There's a Simpson screw made for attaching skinnier plywood to, maybe it's the thickness of the plywood that makes a difference, because that Advantex an inch and a quarter thick versus a 5/8 or a 1/2 inch roof plywood. But it's a different screw, still self-tapping.
And then last question, for interior finishes, what's the best practice for fastening any wood product?
Yeah. So for doors, for interior doors and things like this, we use screws. We advise screws. For running crown and baseboard, we tell everyone still the trim nails. The trim nails still work. Believe it or not, if you hit it square, it'll pin it. Just a regular finish nailer, yeah. Now we do have guys also that butterfly and glue. I don't do that. I've built thousands of houses and I've never done that, but we use a regular 16 gauge trim gun. It shoots it through it.
So when our engineers are looking at the drawings, do they need the schedule for plumbing and electrical, or are they looking at those specific plumbing and electrical drawings so they'll know where to punch?
Yeah, so to get the design team to understand where to punch, two things need to happen. One is some builders aren't going to give you that information because they don't want to take the time to deal with it. So they're going to say, just put it in the normal places. We have standards where we run, depending on where plumbing is in the house, where the toilets are, where the sinks are. We understand how plumbers run things, so we'll give them a couple of options and punch it in a couple of places. Electrical's the same way. We understand how many outlets have to be in a wall, like our design team does. So there's standards that we run. We understand also vertically, when you get close to an electrical panel, how many vertical punches you need. Like, all this is standard. If there are specifics, it's part of the intake process on the final design that you'll be asking your client, hey, are there any specific places you want us to route your MEP for their ease and install?
What type of outlet boxes do you typically recommend, and how do the electricians install it?
So I've seen electricians do it two ways. I've seen them buy the regular blue boxes with nails in it from Home Depot, pull the nails out and put self-tapping screws in those locations. And then they also sell a plastic box from Home Depot that has a fin on the front like a window. And so they just attach the plate through the box through the plate in that box.
Okay. Chad, does the punch mechanism have a rounded edge cut such that it curves, so it rounds out everything?
Yeah, so the punch looks just like this. So that's what's rounding these holes. It makes one punch through. That piece drops to the bottom. We capture that. We recycle that. All these little punches that you see, we recycle that. The end of the day, we run a magnet in the assembly process area where we pick these up. We recycle this. So literally nothing goes to waste in what we do. Oh, right here?
This isn't sharp punch mechanism.
No, this is just how the assembly puts it together. No, it's reasonably not sharp. There are places where we'll have a notch right here, depending on how it goes together. That's sharp. But for here, it's really not sharp. The edges aren't that bad.
Right.
And you're using grommets for electrical wire anyway.
You're using grommets.
You're gonna protect it from the sharp.
Yeah, by code, we have to put grommets in. So for the electricians, there's two things that have to happen. They have to, because they don't have to drill or punch anything, they have to use grommets. And the wires have are run through these little clip standoffs that keeps it away from the metal. And they have like a little collapsible thing on. So they're open, you run the wires and you close it, and it gives you a way to keep the wire from coming in contact with the metal.
With commercial, I know electrical boxes are very specific where they are located. Have you ever considered, or would it be worth it to start to install the electrical boxes in the facility and send it out to the job site?
So that is called MEP kitting. I've done a lot of that. We're staying away from that for NexGen. For NexGen, we just want to produce and send out the steel. There's a ton of liability that goes with MEP kitting. If we put an electrical box in the wrong place, then there's a back charge and all these it's just not worth it. So we quit doing that a while back.
The intake process. So the ROM, you've got the ROM to capture a lot of the measurements. You were talking about some more details a lot about boxes and special case scenarios. Is that something that the design team will ask the builder, or is that something that we're responsible as affiliates to get that information prior?
So as affiliates, you will be attached to the emails that go back and forth between the design team request and your client, so that you can help navigate that. But those will come directly from a design team rep, which we call a project manager on the design side inside of the facility. Right now, as Dan Coy is experiencing, that's me. So we're hiring a project manager and training them to do that, but it's just a communication coordinator because the design team comes up with the list. Now, there is a intake form that Dan is about to see because we're using him as the guinea pig through the process. It's 118 questions. Right on. Yeah, and so this intake form, we'll send it to a lot of clients and they won't want to fool with it. They'll just say, do whatever you normally do. We get some clients that answer all 118 questions. So they're very specific. I love the specific ones because it's like, look, this is what you told us to do and we did it. So, but either way, you'll get the form and they'll either sign that they're going to pass on the answers or they'll sign that they're answering it. And that answers a lot of the how, why, and where on the punches and those kind of things. Okay, so yeah, so where the two dimples go together, if you go to the IBC points you to the AISI 100. That's the metal engineering catalog that the International Building Code bases itself off of. Inside of that code book, you will find verbiage that talks about convex and concave dimples. That is ours. That's proprietary. That's what puts us in the code. So on the back side of this bottom track, it creates a convex semicircle. On the inside of this stud, it's concave. Those convex and concave go together, so when you turn them, they can't slide past each other as long as they're held together by a rivet. That's what that is.
Big chat. So question on that 118 questionnaire, is it divvied up into like electrical,
yes,
plumbing?
Yeah.
So and is it a shared document so that we can send it to our guys so that if they choose not to, I'll just be like, hey.
Well, the corporate's going to send it. That's going to be part of the emails that go out from corporate. You'll be copied on as a relationship manager. We can put it in the toolkit too for you guys.
I'm a builder, so
you build, okay.
I'm asking that from a builder's perspective.
From a builder's perspective, okay.
I don't want to fill out the whole 118 questions because I'm not an electrician and I'm not a plumber and I don't care to be either of those guys.
Yeah.
And so I want them to answer where they want their punches. And so I'm just wondering if it's a shareable Google sheet so that they can collaborate and I'm not trying to send 18 different documents and collect all that stuff.
I love it because he thinks like I do. I'm a builder. I don't want to answer the electrical questions. I want to get it to my electrician. So it's a shareable document. It's a Google sheet. You can download it, that kind of thing. So yeah.
Per code, there's only a certain percentage, right, of the material that can be punched. So what happens if you have multiple plumbing lines or more electrical than is going to go through here? Is there a limit, or is that's all part of the engineering design process?
It's all part of the engineering design process. There's a certain distance we can put them to each other. There's not a limit in the number of holes. Okay. So it's the distance between each other that matter, and so that's why they're rounded, because that allows us, for this it's every 3/4 of an inch. So I can put a plumbing punch every 3/4 of an inch. We rarely do that. We might have two in one location, so yeah.
Yeah, I can see multiple electrical though.
Yeah, we'll run 6 or 8 electrical holes within a foot of each other. Okay. Yeah, to give them chase ways when you have a bunch of wires running through one area. Yeah.
I'm not a builder or anything, so this might not be a valid concern, but the plumbing, you said the electrical holes get grommets, the plumbing does not with PVC, and I can see especially with the supply lines, the plastic, I can't think of PEX.
Yeah.
With the expansion and contraction over time, and especially if you get a water hammer situation, is that not a concern for those edges wearing through?
So the reason the plumbing doesn't get a grommet is because it's in the building code that it doesn't need it. So I'll see a lot of plumbers will wrap their PEX when they pass it in a commercial project because they've been doing it this way for 60 years in commercial. So in a commercial project where they use PEX, sometimes they'll wrap their plumbing together. I mean, there's a couple of there's sleeves they can run it through. But as far as us on our end, we don't do anything with the plumbing hole.
Isn't there fire foam requirements in some areas anyway?
There's fire
foam through your PEX anyway.
Yeah.
And then PEX will go through and then the fire
foam
hole anyways.
This is a really impressive product, isn't it? Yeah. It's not just steel framing, is it? They've created their own steel proprietary product that beats the trash out of anything you can pick up at Home Depot. Really incredible.
I love that we're printing the labels directly on. I thought we were slapping labels on. And as far as human error, this is so much better.
We're printing steel, and it's a printer that prints actually on the machine. And how cool is it even that they do the bottom plate, the side, the top, and all the fill-ins, and it's oh my gosh, that's how you do every panel.
It's easy on playing out of the same steel.
Yeah, 100%. Couple more takeaways?
I love the cleanliness.
Cleanliness.
And the health of the facility.
and the environment that the production team gets to work in.
Yeah.
So amazing.
Yeah,
So
100%. My 17-year-old son starts work here on Monday. Like he's gonna, and my 14-year-old son is gonna start hitting the phones competing against you old timers. I want you to know that Chad and I, we see our future in you. We hope you see your future in us because we're here for the long haul. And I was in a little breakout session yesterday, and someone asked me a question. And their question was, well, when's your exit? Like, when are you going to be done with this? And I sat there for a minute, and I'd just been thinking about how most of my life I was trying to create impact, but make money and have goals, and then there's bigger things I want to do in my foundation, and we went to Ukraine 3 times, and I'm like, I love making money and doing good things. But the answer that came out of my mouth in that moment was, it just hit me with so much conviction in my gut when I said, I will stop when we stop cutting down trees. We are here to stay. We are here to play. We have a worthy, just cause mission, and you guys are a part of it. And the reality is, some of you might be here literally to looky-loo a little bit. Some of you might literally knock down a couple of jobs. And some of you, you're gonna sell $100 million of steel, and you're gonna help knock down the biggest domino possible. So we're gonna do it together. I appreciate you.